In this video, we will look at 5 different properties of exponents. Our first is the product of like bases. The property tells us that if we have a to the power of m times a to the power of n, we can add our exponents together because we have like bases. Notice how both bases are the same. So if we have x cubed times x squared, since the bases are the same, we can add the exponents 3 plus 2 for an answer of x to the 5th power. But we want to make sure we understand why that rule works. So in the expanded form, we're going to write out all the factors of x. X cubed means we have 3 factors of x, and x squared means we have 2 factors of x. If I count up all those factors of x, I have x to the 5th power. Same answer. Now let's look at the quotient of like bases. Quotient means division, so notice how we have a quotient. The base in the numerator and the denominator is the same. I have a to the power of m in the numerator and a to the power of n in the denominator. This rule tells us we subtract our exponents. So I take the numerator exponent minus the denominator exponent. Let's look at the example. 5 to the 4th over 5 squared. Since the base is the same in the numerator and the denominator, I have a base of 5 raised to the 4 minus 2 power, which is 5 to the 2nd power, and this one I can simplify to 25. But again, let's make sure we understand the rule. So in the numerator, I have 5 to the 4th power. That's 4 factors of 5. And in the denominator, I have 5 squared. That's 2 factors of 5. Now I can divide out common factors. For every factor of 5 I see in the numerator, I can divide out a factor of 5 in the denominator. Notice in the denominator, I can write that as 5 times 5 times 1 to remind myself that even though I divided out all the factors of 5 in the denominator, I still have a 1 in the denominator spot. So now in the numerator, I have 2 5s left over, and they're factors, so 5 times 5 is 25 over 1, which equals 25. Now let's look at the power rule. The power rule tells me that if I have a base raised to a power, and then that expression is raised to another power, I multiply those exponents. So this becomes a to the power of m times n. So in our example with w cubed to the 2nd power, I multiply 3 times 2. So my final answer is w to the 6th. But again, we want to make sure we understand why that works. So when I have w cubed and I square it, my base is w cubed. So if I square w cubed, it's w cubed times w cubed. Now, there's 2 ways to think about this. I can go back and use my product of like bases rule. This would become w to the 3 plus 3 power, which is w to the 6th. Or I can continue to expand it. I have 3 factors of w times another 3 factors of w. And if I count up all my factors of w, I have 6, w to the 6th power. The next rule is the power of a product rule. So now inside the parentheses, I have a product, a times b, and that whole product is raised to the power of n. This tells me that each factor in the product, that means the a and the b, are both raised to the nth power. So if I have ab to the 3rd power, a is raised to the 3rd power and b is raised to the 3rd power, a cubed, b cubed. But let's take a deeper look. My base is the product ab. If ab is raised to the 3rd power, that means I have 3 factors of ab. Now, I know that multiplication is associative, which means it doesn't matter how I group the terms that are being multiplied. So instead of AB times AB times AB, I can multiply all the A's and all the B's. And now I can see there's 3 factors of A and 3 factors of B to arrive at A cubed, B cubed. Finally, let's look at the power of a quotient. So again, a quotient is a division problem or a fraction. So if I have A over B to the power of n, the numerator gets raised to the power of n, and so does the denominator. So if I have 2/3, that's a quotient, and I'm cubing it, 2 in the numerator gets cubed, and 3 in the denominator gets cubed. 2 cubed is 8, 3 cubed is 27. 8 over 27. I can also expand it. My base is 2/3. 2/3 cubed means 2/3 times 2/3 times 2/3. Now, I know that when I multiply fractions, I multiply the numerators together, 2 times 2 times 2, and I multiply the denominators together, 3 times 3 times 3, for a final answer of 8 over 27.